Hey students, today's lesson is on solving systems of linear equations by elimination. Here are the steps that we'll solve. First, we're going to multiply, if necessary, one or both of the equations by a constant so that at least one pair of like terms has the same or opposite coefficients. Step 2, we'll add or subtract the equations to eliminate one of the variables. Step 3, we'll solve the resulting equation for the remaining variable. And step 4, we'll substitute the value from step 3 into one of the original equations and solve. Let's try it. Okay, example 1. Here's our system. X plus 3y equals negative 2, and x minus 3y equals 16. Now, we said that we would find at least one pair of like terms has the same or opposite coefficient. So our x's have the same coefficient and our y's have opposite coefficients. So step 1 is already done. And I'm going to use the y terms. Y terms are opposites because I think it's easier to add the system than to subtract. So we're going to go ahead and take these two equations and add them. So we're already lined up with the x's right on top of the x's, the y's on top of the y's. So we're just going to do x plus x is 2x, and 3y minus 3y is 0. So that's eliminated. That's our goal. And negative 2 plus 16 is 14. So 2x equals 14. All right, step 3 was to solve this resulting equation for the remaining variable. So x is our remaining variable. I'm going to go ahead and write this over here. 2x equals 14. We're going to divide by 2 to solve. X equals 7. Okay, and then step 4 was to substitute this value, x, into either one of the remaining equations to solve for y. So let's go ahead and use the first equation, x plus 3y equals negative 2. But we're going to substitute 7 for x. So we have 7 plus 3y equals negative 2. We'll subtract 7 from both sides. And we get 3y equals negative 9. We'll divide by 3 and get y equals negative 3. So our solution here is 7, negative 3. All right, a lot of steps, but that wasn't so bad, right? Okay, let's try another example. Here we have another system. Here's two equations. We don't have that same luxury that we did last time where one of the coefficients for one of the variables is already the same or opposite. We don't have that. But I noticed that if I multiply this equation by 3, then our x terms would have the same coefficient. Or even better, if I multiply by negative 3, they'll have the opposite coefficient, which I happen to like better. So that's what I'm going to do. So I'm going to start with this negative 2x minus 4y equals 14. And I'm going to multiply both sides of the equation by negative 3. So here I need to use the distributive property to distribute that negative 3 to both terms on the left. So negative 3 times negative 2x is 6x. Negative 3 times negative 4y is 12y equals negative 42. So 6x plus 12y equals negative 42. So step 2 is I'm going to take this equation that has a negative 6 as the coefficient of x, and I'm going to add it to this equation to try to eliminate my x terms. So I'm going to take negative 6x plus 5y equals 25, and I'm going to add that to 6x plus 12y equals negative 42. Negative 6x plus 6x is 0, so I've eliminated my x's. 5y plus 12y is 17y equals 25 plus negative 42 is negative 17. I'll divide by 17 and get y equals negative 1. Oops, sorry, that was step 3. I got ahead of myself here. So I'm going to take this equation that I ended up with from step 2, 17y equals negative 17. Now I'll divide by 17 on both sides and get y equals negative 1. Okay, now my fourth step is going to be to take one of my equations and substitute y, negative 1 in place of y. So let's go ahead and use this bottom one here. Negative 2x minus 4y equals 14. I'll substitute negative 1 for y. So negative 2x minus 4 times negative 1 equals 14. Negative 2x plus 4, negative times negative is positive, equals 14. I'm going to subtract 4 from both sides to isolate my variable. Negative 2x equals 10. And then I'll divide by negative 2 and get x equals negative 5. Okay, so if x is negative 5 and y is negative 1, my solution is negative 5, negative 1. Okay, go ahead and try a few of these on your own. I'll see you soon.